Hi, thanks for tuning in to Robots, Androids, Cyborgs, and Zombies. I'll be your host today, Blueberry Wizard. We're going to check out just some random posts today, and as time goes on, we'll get it together. So, here from July of 2016, they have a stingray robot that swims with the heart of rat heart cells. So, understanding how to build machines from heart cells could lead scientists to be able to build entire living artificial hearts. This is from Live Science. Stingrays and related fishes have flat bodies with long wing-like fins. The fins undulate in the waves that ripple from the front of the fins to the back, energy-efficient motions that help the fish glide through the water. Well, researchers sought to build a robot that emulates that efficiency and maneuverability. And they began with a skeleton that mimicked the shape of stingrays that were made of gold. It was chosen because of its chemically inert nature. They put a thin plastic over it and placed heart cells. When they stimulated, they contracted and pulled the fins downward. So they put rat heart cells that are stimulatable by light. I think that they're bred that way, but they're light activated, and they stimulate them. It says it's alive, but it's not an organism. It can't replicate or reproduce. Crazy, right? So they're using pieces of animal tissue in robots. This is androids, in my opinion. So there will be living tissue in a lot of the future robots. Some of this, at first, of course, will be harvested from actual animals, but as time goes on, they will easily be able to replicate the cells needed in a laboratory of some sort. And so, although they will have a legacy from a living creature, they themselves will not be of an actual living creature. And with the advances in cells, biology, gene programming, there will be tissue created like like someone designs a car. They'll design tissue for a specific robotic purpose and be able to grow that, whether it's creating a plastic-like lattice that the tissue grows upon, or if it's actually going to be completely programmed into the DNA of the tissue to just simply grow for the robot, for the purpose of the robot. It's really crazy, exciting times. Here's one from Science Daily from 2016. Artificial muscle for soft robotics, low voltage, high hopes. So what we have here is some sort of plastic that at low volts will contract. Sandwichable, nanotubes. Soft robots do a lot of things well, but they're not exactly known for speed. The artificial muscles that move soft robots, called actuators, tend to rely on hydraulics and pneumatics, which are slow to respond. But dielectric elastomers, they're soft plastic materials that have good insulating properties, could offer an alternative to pneumatic actuators, but they're currently requiring complex and inefficient circuitry and use higher voltage. Well, we think this has a potential to be the holy grail of soft robotics. This Paulson School of Engineering, the Harvard John A. Paulson School of Engineering and Applied Sciences (SEAS) have developed a dielectric elastomer with a broad range of motion that requires relatively low voltage and no rigid components. They published their work recently in Advanced Materials. We think this has the potential to be the holy grail of robotics. So they have essentially plastics, dielectric elastomers that can move. So even at very small sizes, things are basically going to be living robotic worms. So the tissues themselves, the elastic stuff, can be incorporated with hydraulics for finer actualization, articulation. Like, can you imagine a robotic finger with some sort of rubber on the end? Okay, bink. That'd probably work really well. But imagine now if instead of just a rubber, you have a dielectric elastomer, which then will provide another level of tension or relaxation or elastic pushing. Will definitely be incorporated between living tissue incorporated into robotics and then soft robotic tissue, dielectric elastomer tissue, and things are getting amazing. Who knows what this will change? This could change everything for soft robots. I mean, it could really expand a lot. This low voltage muscle, basically, like formable muscle. This is one from March 3rd, 2017, from Science Alert by David Neild. Science has created a hydrogel fabric that's 5 times stronger than steel. So this is another thing that could change robotics. It's a flexible material, but it's impenetrable. I mean, talk about bulletproof. And these hydrogels are 5 times harder to break than carbon steel, but still easy to bend and stretch. The combination of properties means the new fabric could be used on a basis for artificial ligaments, tendons, and designs designed to help the body heal, or in manufacturing or fashion, where a very tough but elastic material is needed. So this hydrogel that they've invented can be used as robotics expands as basic tendons. We have this broad range of materials that are being explored and discovered, and they're all coming back together. They're going to come back together. Graphene was just discovered a handful of years ago, and immediately it was integrated into industry almost immediately. It's been a real game changer. Other things like this, once they incorporate with other technologies, and that goes through a few generations of production, man, things are going to be really amazing. Those clunky robots from the 50s TV shows, that's not at all what they're going to be like. They're going to be slim, sleek, strong, and mind-bogglingly intelligent. What people don't realize, what I think very few people realize, is that once you have a cloud of uh, AI intelligence, other robots from all over the world will be able to access that level of reasoning, that level of intelligence. You won't need to have a quantum computer in your robot. You could just have a quantum computer hooked up to the cloud that your robot has access to, and it will be a 10,000 IQ. You get a little Christmas toy. It's a little ball with a 10,000 IQ. That's just what talk about cart before the horse. I mean, the level of AI intelligence is going to just be a tide that will absorb all computers, all robotics. Once you have access to that level of intelligence, then it changes what's possible at the user end. I mean, for example, right now I use Adobe. I have it on my computer. I really like it. But what's to say that Adobe couldn't just have a big giant server that I go log on to online and just use their big computing system? If they have a giant quantum computer and can handle all these crazy functions much more rapidly, it would make sense that I would just simply use their computing capacity. Well, same thing with robotics. These little robots are going to be more intelligent than the average bear. Physicists, this is from March 3rd this year. Physicists, 2017. Physicists say they've created an impossible new form of matter. Supersolids. The most compelling evidence yet that supersolids exist. Actually, we're going to skip that one today. This is exciting. This is pretty exciting indeed. A giant neuron has been found wrapped around the entire circumference of the brain. There's one neuron that they just discovered that goes all the way around the brain. This is a mouse's brain, but almost definitely we have them as well. It says, for the first time, scientists has detected a giant neuron wrapped around the entire circumference of a mouse's brain. It's so densely connected across both hemispheres, it could finally explain the origin of consciousness. This is big deal. I'll get this up next week. We'll pick up some of this stuff. And as time goes on, it'll be like newscasts and I'll have guests and stuff. So keep tuning in, okay? I really appreciate that you're here. Subscribe and like, see where this goes.